equations is horrible to do in a short semester. I personally would rather do it in a full semester. I did it in the summer, and I don't know how much I got out of it compared to if I have a whole summer and I have time and a study group and things like that. I do like Calc 3 in summer. So if for all of my engineers here, if you're going to take something in summer 2, Calc 3 is easy. Doesn't mean we don't have to work, but the math is pretty simple. If anything,
Calc 3 about?
Calc 3 is multivariable calculus. So all of a sudden we have x's, y's, and z's. In fact, we're going to go into vectors, and of course that could be in any dimension. So you're integrating among several variables and differentiating. Very simple, very easy. Melky, I just got yours. It looks like it's separate documents. I want a single document. If you can resend it to me as a single document, okay? Instead of separate PDFs, I want a single PDF, all pages attached to each other. And Melky, what are you using? You can chat to me. What program are you using? Oh, notes from your iPhone. Is that right? Yes. So do a quick Google search, not during class, after, to see if there's a way to stitch them together using notes. Okay. Otherwise, get Cam Scanner. Okay. Sorry, I'm recording that. So differential equations. We're going to do 3 sections of this part of the book. And I'm thinking about if I do an extra bio project, it would come from the DiffyQs section. So I'm still thinking about that. So give me another minute on that. I talked to Caleb and Niant possibly about that. I think I had mentioned to everybody, but still haven't decided. You can start your projects now, right? And your projects are independent study on a particular section of the book. Please read the examples in this section and then attempt the problems. A lot of times, like I know for the computer science version, for the probability project, it'll say use the formula on this page. And so do that, please. Use the formula, right? Use the formulas they give you, and then it's just about integrating to get the answers. So when you take DiffyQs, because it's all applications, you're going to get freaked out a little bit at the beginning, right? Because they're going to be talking about all these models, population models and physics models, and like population growth and motion of a spring, all of this, the force needed and all of that. So just don't freak out about it, and know that the book has got all these models in it, and you should be able to look at them and recognize, oh, they're using this function, or they're using an exponential function, they're using a logarithmic function, right, to model certain things. So again, you could go in there and just freak out, but don't, okay? The math you'll be able to do. And so we're going to start doing some of that math now. So first of all, what is a DiffyQ? What is a differential equation? So examples of a differential equation. Examples of, and that is 7.1 is DiffyQs, right? Just what are they? Examples of DiffyQs. So y prime equals x times y. So what do you see there? You see the original function y, unknown what it is, and x times that function, and the derivative of the function. Okay, so you're going to have some equation equating a function and a bunch of its derivatives, maybe y prime, maybe y double prime, maybe y triple prime, maybe a combination of them. Okay, so it's an equation with the function y, derivatives, and possible x's or e to the x's or other functions, right? So this is called a first order Diffie-Q. Why do you think first order?
Single differentiation.
Exactly,
a
single derivative. Exactly, and so you certainly could see y double prime plus y equals plus y prime equals 2y. So there's a second order differential equation. And our whole idea is, so what is a derivative? It's how something's changing, right? So the derivative is how something's changing. So we could see the original function here. We can see how it's changing and how it's accelerating, right? We could see, so let's pretend this is something moving in space, right? So here's our original trajectory, here's our speed, and here's our acceleration. And we're saying, is there a solution to this, right? Kind of thing. So the first answer is, how can you find the answer? The first question is, how do you find the answer? Can you find the answer, right? And that's kind of, we're dealing with that a little bit right now. Can you do the derivative? Okay, if you do the derivative, is it finite, right? Does it converge? So it's a little bit of that in a sense of, is there even a solution to this Diffie-Q? And then how do you find them is you're going to kind of go through processes like we are now, how to differentiate, how to integrate, right? If that doesn't work, try this. So you're going to do the same thing in your Diffie-Q's class, right? I don't mind you trying Diffie-Q's in 6. I think it's easier than Calc 2, but you can't base everything on what I believe. That's for sure. So, like I'll say, I swear to God I'm an atheist, kind of thing. So you can't trust me on things. I like weird thoughts like that, things that can't exist, right? How could you swear to God if you don't believe in God, right? But anyone taking Calc 3 in summer 2? Nice. You'll be fine. Charlie, what are you doing?
Yeah, I will.
Good. Get in there now. Don't wait too long, okay?
Yeah, I registered for both differential equation and multivariables, but I was thinking to
one or the other, Charlie. Don't do that to yourself.
Yeah.
One or the other. Calc 3 is easier.
Okay. I'll do it. I'll talk to you after.
Okay. All right. I don't want you to do that to yourself. That's just pure punishment. I know you love math, but so how do we find a solution? How do we estimate a solution? How do we verify a solution? That's what we're doing in this chapter 7. Okay, and we'll finish chapter 7 this week. Early next week. I think I will finish it on Tuesday for sure. So Thursday, Monday, Tuesday. Wednesday we're reviewing for the test. I like to just give you a mock problem, a fake, like if I made the test, this is your test question, and I'll give everyone 20 minutes to do it, and then we'll go over it. So that's the plan for Wednesday, and then Thursday we take the test, right? So anyway, I keep getting distracted today. I'm sorry about that. So examples of Diffie-Q's. It's hard to see the answers and hard to come up with the answers. Like this particular answer is y equals e to the x, right? Right. So there's more than one answer. There's more than one answer here, right? But this one is pretty clear, right? So what's y prime? It's e to the x. What's y double prime? E to the x. And what's y? E to the x. So I get e to the x plus e to the x equals 2e to the x. Yes, it worked, right? So the first thing we're going to do is I'm going to say to you, I'm going to give you the solution and you verify it for me. And that's our main problem type in 7.1. Given a solution verify it satisfies the given diffie-q. So in the book, I like 1, 2, 3, 4, 5. I like 1 to 5 in the book. So homework number 1 to 5. Odds, so 1, 3, and 5, right? In MindTap in 7.1. And there's 2 other problems in WebAssign that are similar to the book problems. So let's look at 1. This is number 2 in the book, okay? So 7.1, number 2. So basically, I'm just going to give you a solution. I'm going to give you a diffie-q. I'm giving you that my solution is y equals negative x cos of x minus x. And so there's 2 kinds of solutions. There's a general solution, which is a family of functions, with the mother function. And then there's an initial value solution, and this one is an initial value solution. So it says if I plug in pi, I get 0. So this is an initial value solution. So so meaning when we integrate, we're going to get a constant of integration, right? And that constant of integration could be any constant. And so I'll get a family of functions, right? If c is 1, if c is 2, if c is 3. And when I give you an initial value, I'm saying, let's find the value of c. Okay? So, and here's my diffie-q. So this is my solution. This is my initial value. And my equation in this case is xy prime equals y plus x squared sine x. So there's our general idea. Pretty simple. I give you a solution. You got to do some work and plug it in and see if it works. So obviously, what am I missing here? Well, I have y. X's are x's. X's are obvious, right? What don't I have to plug in here is y prime. So I just have to find y prime. So let's find y prime real quick here. So anybody get the same derivative as me there? So I did a product rule real quick, right? Anybody there yet? Anybody agree with the derivative? Charlie, you there? Thank you. Adrian, I never got anything from you. So anyone else? I need someone else to verify we got the right derivative here. Yes, Eleanor, thank you. So Charlie and Eleanor say yes. So now I'm plugging. Go ahead. Yeah, okay, Adrian, thank you. So now I'm plugging in, right? So x, y prime should equal y, so that's minus x cos x minus x plus x squared sine x, question mark, right? Like when we were plugging in values when we first started doing this stuff. So I can clearly see an x squared sine x on both sides. I can see the minus x cos x on both sides, and I can see the minus x on both sides. So check, right? I can see this is here, this is here, this is here. It worked. So it doesn't make that much sense about the initial value or a general solution yet, but it will. But this first piece is just saying, hey, if I give you a solution, you should be able to verify it's a solution, right? And of course, this means, just like we did all the time when we got a solution of a quadratic equation with the quadratic formula, we would want to go take that zero and plug it back in and see if we got a zero from it. So, right, same stuff we've been doing forever. The next one's a little bit more difficult. So this is 4. So that you got one just like this in your homework, and you've got one like number 3 in your homework. I should probably do 3. 3 is more difficult. Let me do 3. So I'm sorry I'm doing some of your homework here for you, but I don't think you really care. Especially because you're worried about the test at this point, right? You're like, don't teach me anything else. So it says, for which values of r does, so find r such that, that's an r, believe it or not, that y equals e to the rx satisfies Adrian, I got it, thank you. Satisfies 2y prime, sorry, 2y double prime plus y prime minus y equals 0.
You said I got it?
Yeah, I got your
All right.
an email from a doctor. So find r such that this particular equation is satisfied, right? And so I just need a little bit of work here. So clearly we have y, and y prime should be an easy chain rule, right? R e to the rx. Is that agreeable to everyone? And then y double prime is I'm going to get an r squared out front, y r squared e to the rx. Hopefully that's okay with everybody and everybody's seeing that. If you need a moment, let me know. How are we doing here? Okay?
Wait, Robert, is the original equation 1 minus y? Or is that supposed to be it?
I'm sorry, show that. Sorry. It's pretty bad. So now as we plug in, right, we get 2r squared e to the rx plus r e to the rx minus e to the rx equals 0. And we're going to factor out the e to the rx, which by the way can never be 0, right? So 2r squared plus r minus 1. So that piece could be 0, right? So for some values of r, I could get 0 out of this, right? And I'm splitting the middle term here. So I get r is 1/2, or r is -1. Anybody else get there? Let me know, please. So the initial answer had a constant in it, unknown, right? R, some value of R, like your constant of integration, right? And then we found two possible values for that to solve the second order differential equation. What's kind of ringing a bell there to you? Why would I get two solutions? Well, what does your gut say about why would I get two answers? If I found the general solution, why would I be getting two answers out of that? Because of y double prime, right? Second order. Just like when you had an x squared, you got two answers, right? You might have not had two answers, but you had up to two answers, right? So the general solution that we got was y equals e to the rx, and then an initial value solution or a specific solution, right, would be something like e to the negative x, or e to the 1/2 x, right? So I got two. Notice in the general solution, there's this unknown variable that's a constant, right? And in the initial value solutions, there's none, right? There's no plus c anymore for the integral, right? Kind of idea. So it turns out that show that y equals a e to the r1x plus b e to the r2x is also a solution. And so right at this point you're going, what the hell? How the hell am I supposed to know this? They don't expect you to know it yet. In fact, most of your time in DiffEqs is going to be finding ways to find these solutions, right? We're going to do a very simple one or two versions of it next week. But right now we're just trying to verify things work. So let me take this as R1 and this is R2, right? So show that a e to the negative x plus b e to the 1/2 x is a solution. So where a and b are numbers, right? A and b are numbers. Just making sure I have it written down right. Yep. This particular thing is called a family of functions. This is a family of functions, or a general solution. This is a family of functions, or a general solution, right? And then when I find specific values of A and B, then I've got an initial value solution. When I found initial values of R, I got an initial value solution. When I find values for A and B, I have an initial value solution. So what do I need to do with this new piece? Is I need to do a derivative and a second derivative, right? So I'm showing that y equals a e to the minus x plus b e to the 1/2 x is a solution to 2y double prime plus y prime minus y equals 0. So again, we're finding derivatives for y and y prime and plugging in, right? So if y equals a e to the minus x plus b e to the 1/2 x, then y prime is negative a e to the negative x plus 1/2 b e to the 1/2 x. And then I'm getting y double prime. So you just keep working. And then let's see if we get anyone that gets the same derivatives as me. I'm getting a little sloppy here. Nice, Ash. Thank you. David, yes, same? Yeah, nice. Anybody need a minute here? Okay. So now we're just plugging those back into that differential equation, right? So 2 times a e to the minus x plus 1/4 b e to the 1/2 x plus the opposite of a e to the minus x plus 1/2 b e to the 1/2 x minus the original function a e to the minus x b e to the 1/2 x should equal 0. Everything should cancel. And I can see 2 of those going here. Yep, I see a 1/2 and a 1/2 and a minus 1. So everything goes away. Nice. That's as difficult as this section gets. So you can see why I'm not afraid to teach this to you. We just have a differential equation, plug it in. I think this is one homework that you can do today and get it checked off and then not think about it anymore. One, I don't test on it. But 2, if I do give you, if I ask you to find an initial value solution and then you check it, you know how to check it now. That's basically what we're doing. I don't think much of the homework we do in Chapter 7 will be a bad thing for you to do before, but I do also like the thought of, as soon as I'm done with my test, I'll take a day off. I'll take my test Thursday, I'll take Friday off, And on Saturday, I'll do Chapter 7 homework. That's not a bad strategy to think about. Most important is that you're doing these old midterms and the midterm material and the finals, right? And you're asking me questions Monday and Tuesday, and then Wednesday we're practicing for the test, and Thursday we take the test. So, guess what? I don't want to do anything else today. Of course, I'll be here till 1:30 today. Okay.